Binary search is another search algorithm, and it checks to see if it can find an item within a list. So what it does is that it searches an ordered list. Um, it is a divide and conquer algorithm. The first thing it does is that it checks to see if there is only one item in the list. And if that is the case, then it checks to see if that item is the same as the search item. And if it is, then it will return true. And that will be the end of the search. Otherwise, it divides the list into two halves and finds the mid value. Now, if the search item is the same as the mid value, then again, the process ends. Otherwise, if the search item is smaller than the mid value, then the left side is used for the next search. And if it's larger than the mid value, then the right side is used for the next search. And this process continues until the search either finds the item or the search is complete and no match is found. Now let's have a look at the program for binary search. Here we have a function which is called binary search, and it takes two values as input. The first one is the list itself, the entire list, and the second one is the value that we want to search for. Then we check to see if there is only one item in the list. And if that is the case, we want to see if that one item is equal to this value. So we say if length of our list is equal to 1, then return this. And we know that whenever we have two equals, it will check the value on the left is equal to the right. And if it is, then it will return true, and otherwise it will return false. So if the length of a list is 1, so if there's only one item in the list and that item is equal to this value, then it will return true. Otherwise, what it's going to do is it's going to find the midpoint of our list. And the way it does that is through doing a floor division. So floor division is when you have two forward slashes. It's also called integer division. And the way it works is that it divides this number by the number on the right, and then it rounds it down to the nearest integer. So once we have the midpoint, next we want to see if the search item is less than the midpoint, then we want to search the lower half of the list. So we say return binary search, and this is the name of the list, from the beginning of the list up to the midpoint, but excluding the midpoint. And we pass the value. So here we are using recursion because we are calling the function again. So we're calling the same function again here, except that this time we want to do the search not on the entire list, but for the first half. Now, if the search item is greater than the midpoint, then we want to search the second half of the list. So we say return, and then we search from the midpoint until the end of the list. And again, we are calling this function, except that this time we are passing the second half of the list. And of course, another possibility is that the midpoint is equal to the value that we want to search for, in which case we return true, and that will be the end of the search. Now, the best way to understand this algorithm is to run the code. And if you have an algorithm that's a little bit difficult to understand, it's always really helpful if you add lots of print statements in your code so that you can see exactly what's going on. So here what we have is the list. So this is an unordered list. And we know that the binary search expects an ordered list. So before we call the function, we need to sort the list. And then we call the function and we pass this ordered list and the value we want to search for. In this case, it's 90. So let's run the code. Once it calls this function, it will print the length of the list, which is 8, and the list itself. We can see that it's ordered and it finds the midpoint of that list. So it's the mid is 4. So 0, 1, 2, 3, 4. That is the mid, number 12. And it's printing that value. It's actually telling us what the mid is. So that's what's happening here. Once we've done that, we check to see if ls mid is greater than value, which it's not. Otherwise, we check to see if it's less than value, which in this case it is. So next time it's going to call the function again, but this time it will search from the midpoint to the end of the list. So we want to search the second half of the list. Okay, so we can see that the next time it goes round, it's actually passing the second half. So that's 12, 19, 45, and 90. This time the midpoint is 2, so that's 0, 1, 2. And it's telling us what it is. It's 45. And 45 is less than the value we want to search for. So this time we want to call the function and pass from the mid up to the end. So next time we go around, our list is going to be 45 and 90. Now this time the midpoint is 1, so that's 0, 1. And ls mid is not greater than value, and it's not less than value, but instead it's actually equal to value. So it will return true. So you can try this with various different lists with different lengths and also different values that you want to search for, and see what happens with the algorithm. Now I just want to point out that we have 3 if statements here. ls mid is greater than value, ls mid is less than value, and ls mid is equal to value. All of these if statements are related to each other. So instead of this, we could also have said if, elif, and this could have been just else, because if the midpoint is neither greater than nor less than value, then they must be equal. So if I say else here, it's exactly the same as the code we just saw. But the code we just saw is clearer to understand, so I prefer to leave it that way. But I want you to know that this is exactly the same. So if I run it again, we get exactly the same results.